Hi everyone. Hello. Good afternoon everyone. This side Sunny Singh from NG Networks. This session is regarding the OSPF workshop that we are going to conduct it today. So I hope all are doing good. So before starting the workshop, I want to say something. When during the workshop, if you are having any questions or doubts, just give me a moment. Sorry for that. So during the session, if you are having any questions or any doubts, just do one thing, just paste your doubts on the chats and let me know about your doubts. Okay, I'm just sharing my screen. Just let me know once it is visible. Just say if it's visible or not in the chat sections. Everyone, is it visible to everyone? Okay, fine. So let me start now. So first of all, why do we use an OSPF? The question might be coming in your mind, like what is an OSPF? What is that actually? So first of all, just understood that I'm having this kind of scenario which I need to set up in my company. I have to set up a company where I have to communicate between the different devices. So I need to enable the routing inside my company. As OSPF is an interior gateway routing protocol, so I will be creating this topology, this kind of topology, not like this exactly, but this can be the scenario where we need to implement the OSPF. Company has given me a requirement that I need to set up and uh, I need to connect my all the users inside the company and I need to enable the routing between them. So how to do that? So I have to decide any routing protocol through which I can enable the routing between my users and let them communicate with each other. So for that, I am having one protocol. Actually, we are having many protocols, but the OSPF is one of the best protocols that we use in the real time and in the companies. So like here you can see the area 1, area 0. What is that? You might be wondering what is that. So let us first of all understand why do we require an OSPF first. So first of all, let us understand how do the router functions. How do the router functions actually? When you are having two devices, router works within the two different network addresses. So if you can see in the figure, I'm having a 10.1.10/24, which is having the network ID of 10.1.1.0, and I'm having a device of 21.1.10, which is having a network ID of 20.1.1.0. So when I want to communicate between the two different devices, which is residing in the two different networks, then I will require a device known as a router, right? So how do they function? So one packet will be initiated from the PC2, that would be 10.1.1.0, and the another it will having the source IP. This is my source IP and this is my destination IP. In this packet, the destination IP would be 20.1.1.10. So here, when you are initiating a packet, it will first travel to the router and then router will maintain a routing table. This is our routing table. This is our routing table. So router will just look for the routing table. Is the route present in my network? Is the routes that are present in my routing table or not? So first of all, what is the network ID of this? 10.1.1.0? Yeah, is that it is present? It is directly connected. So yeah, it is present. Now it will check for the destination IP. Is it present in the routing table? Yes, that is also present. But where it is present? It is present on the fast Ethernet 0 by 1. So it will just forward this packet onto the F0 by 1 and it will take this packet to the destination. This is my source and this is my destination. This will travel the packet from just a request packet. I need to send a reply as well. Then what I need to do? One reply packet will be initiated from here, which will contain the source IP as a 20.1.1.10 and the destination IP as a 10.1.1.10. What will happen? This packet will again travel to the router. Router will again check its routing table. Is the source IP present in the network? Yeah, it's definitely present in the network. Is the destination IP present in the network? It is also present in the network. But where is the present? It is present on fast Ethernet 0 by 0. So what it is going to do? it is going to transfer that packet on the fast Ethernet 0 by 0, and with the help of that, it will be sent to the PC2. This is how two-way communication is being taken place into the OSPF. This is how the two-way communication takes place, not into the OSPF. It is a functioning of a router, how the router functions. So this is how the two different networks can communicate. But now the question comes, like for an example, in my company, it is not possible to have only one router, because maximally we can have 8 ports on a router. And if I'm having thousands of users in my company, then how they will communicate? I would be requiring more than one routers, right? I would be requiring more than one routers. Okay. Any question till here? How the router functions? If yes, no, any problem over here? Any questions? Let me see the chat. Okay, fine. Then let's move ahead. Let me show you how the router functions in a practical scenario. Like this is a topology. Here, what we'll do, we will just ping the packet. We will just ping from source to destination, and let us check how the packet is traveling. Just do one thing, go to desktop, just go to command prompt, and then try to ping the network. That is my destination. Here see, previously when I have pinged, my first packet was dropped. The reason behind this is ARP, that is an address resolution protocol. I am pinging destination IP, but we don't know the MAC address. So ARP does what? ARP resolves the MAC address for you. And in this case, the proxy ARP is working. So let me just ping it out and see what happens. This packet travels to the router, and then it will travel to the destination. See, it is checking, it is going to the router, and then after checking the routing table, it will be forwarding to the destination again. So this is how the request and reply packet is getting completed. See, one ICMP packet got completed when it has gone to the router, it has checked this routing table and then sent to the router again. It is sending it again. Then it will again check the routing table, and then it will forward to the destination. This is how the router is working. Now, let us try to understand, why do we require a routing then? Router is working like this, then why do we require a routing? So let us try to understand that also. Let me take you back to that. So let us take an example first. Just understand that if I am having one router, then it's fine. But if I am having R1, R2, R3, I'm having multiple routers now. Because from a single router, it is not possible to connect all the devices in my company, because there are n number of users. There are not a single user or a two user or three user. There can be there can be around 1,000, 10,000, like Capgemini, Infosys. There are different MNC companies where there are 10,000s of employees working in the single company. So how they will communicate? So just understand there are more than one routers, and just understand there is one user over here, that will be A, and there is another user over here, that would be B. Let me give the IP address and just assume that the interface is F0 by 0 over here, F0 by 1 over here, F0 by 0, F0 by 1, F0 by 0, and F0 by 1. Now here comes, if I give the IP address 10.1.1.10/24, and on F0 by 0 the IP address would be 10.1.1.20/24. Let me take IP here as 20.1.1.10/24 and 20.1.1.20/24. Here I am taking 30.1.1.10/24. Here I am taking 30.1.1.20/24. Let me take on device on the B device 40.1.1.10/24. And on the F0 by 1 I am taking 40.1.1.20/24. So like this is a scenario. Router always works within the different networks. So I have taken different networks on the single router. So by default, R1 will maintain one routing table. R1 routing table will be different. R2 routing table will be different, and R3 routing table will be different. So in the R1 routing table, I will be having two different networks, F0 by 0 and on F0 by 1. F0 by 0, the network would be 10.1.1.0. F0 by 1, the network would be 20.1.1.0. And on R2, F0 by 0, the network would be 20.1.1.0. And on F0 by 1, the network would be 30.1.1.0. Similarly, on R3, F0 by 0, the network is 30.1.1.0. And on F0 by 1, the network is 40.1.1.0. So now let us try to understand. Previously, when the single router was there, the router was able to communicate because it was having only two different networks. But now let me tell you, if the packet initiated from A to B, the source IP would be 10.1.1.10/24 and the destination IP would be 40.1.1.10/24. So when this packet will travel to this R1, R1 will check its routing table. Is the source IP present in the network 10.1.1.10? Yeah, is this present? But is the destination present in the network? The answer would be simple no. Destination is not present in the network routing table. So what do we do now? If the routing table does not have that source and destination, it won't be able to forward the data. Obviously, the packet is going to drop over here. So the communication is not going to take place. Definitely, this is the scenario. If you initiate the packet from here as well, from B to A as well, if the packet is like 40.1.1.10/24 and the destination is 10.1.1.10/24, then this packet will first go to R3 and then R3 will check its routing table. Is it present? Source? Yeah, source is present, but destination is still not present over here. So the packet will be dropped over here as well. So right now, A and B, which are indirectly connected networks, aren't able to communicate with each other. They are not able to communicate with each other. Then what do we do now? Then comes the concept of routing. Then comes the concept of routing. And in the routing, we are having two particular types. It can be a static routing and it can be a dynamic routing. Routing, we are having a two types. One is a static. Sorry, just give me a moment. One is a static routing and another one is a dynamic routing. Static means like when you are manually configuring the routes in the routing table. In the previous example, we were having different routers and they were only having two routes in the routing table. What about the other routes that were not present? So in that static routing, what I need to do? I need to manually configure those routes into the routing table. Let me give you an example. In the dynamic, it will automatically create its routing table with the help of protocols. In the dynamic, we are having two different protocols. One is an IGP protocol and another is an EGP protocol. IGP stands for Interior Gateway Protocol and, and EGP stands for Exterior Gateway Protocol. Okay. So IGP is an interior one and EGP an exterior one. Interior one means like, for an example, just take an example, like Infosys, Capgemini, Cognizant, those are MNC companies. So they must be having multiple sites. One site is in Chennai, one site is in Bangalore, one site would be in Delhi, etc. etc. There are multiple sites. So there are different types of protocols that are being used when I need to communicate between different networks. So they all needs to communicate with each other as well, and inside that their particular site, in the Chennai site as well, there are 10,000 of employees, 10,000 plus employees, here as well 10,000 plus employees, here as well 10,000 plus employees. So how do they will communicate within the particular location? So for that particular location, we are using one protocol, that is an IGP protocol. Inside the particular autonomous system, we give the autonomous system numbers to determine that they are following the similar routing policy within the particular autonomous system. So here, when we are talking about the single location, we will be using an IGP protocol within the location. Here as well an IGP protocol is used. Here as well an IGP protocol is used. But what about when this Chennai, Bangalore and Delhi wants to communicate with each other? They all will go to ISP. ISP is nothing but an internet service provider. They all will go to ISP, and what will be happening? Just assume this is given an autonomous system number as 100, and this is given an autonomous system number as 200, and this is given as autonomous system number as 300. Then when these three different autonomous systems are communicating with each other, they would be requiring another routing protocol, that is an EGP, exterior gateway protocol. And IGP stands for an interior gateway protocol, which is working within the same location or the same autonomous system. And EGP is nothing but when the two or more autonomous systems are communicating with each other, we will require an EGP protocol. And now in the IGP protocol, we are having basically three major protocols that are being used in the industries. First one is RIP, Routing Information Protocol. Second one is OSPF, that is an Open Shortest Path First, and the third one is EIGRP, that is an Extended Interior Gateway Routing Protocol. And in the EGP protocol, we are only having one type, that is an BGP, Border Gateway Protocol. So in the today's lecture, in the today's session, we are going to discuss about the OSPF, how the OSPF is working, and what can be the scenarios where OSPF is used. So to let you know about, OSPF is most widely used in the industry. The reason behind it is like it is supporting unlimited routers. Now let us understand the routing first. Let me tell you how the static routing is creating a problem to us. Then that's why we require a dynamic routing. So first of all, this is just take a scenario like here two devices are connected. One is 10.11.10 and here 21.110. I have shown you this example as well. Now once the packet will initiate from 10.11.10, 21.110, it will be dropped over here. So I have configured a static route over here. Static route, the simple configuration is you have to give the IP route and you have to add the destination networks that are not present in its routing table. For an example, on the router 0, we are only having 10.1.1.0 and 30.1.1.0. Rather than that, like 40 network, 50 network, and 20 network that are not present in its routing table. So we need to manually add. We need to manually add to the each and every router. How? By giving the command IP route destination network ID destination subnet mask and either by next hop IP address, either by next hop IP address or by exit interface. What does this mean? Let me just give you one example and let me take you to the lab as well. So just take an example here. I need to add the 40 network. Then what can be the command? So for that command, I have to type IP route 40.1.1.0. Now see, for 40, what is the subnet mask? The subnet mask is 24. That would be 255.255.255.0. And what is the next hop IP or exit interface? Next hop IP means the next router's IP address, where the next router is connected to that particular router. So when we talk about router 0, it is connected to the router 1 on the F0 by 0 interface, and the IP address of that particular interface is 30.1.120. So I have to give 30.1.1.20 or exit interface. Exit interface means from where the route is exiting from that router. So on the router 0, it is exiting from the F0 by 1. So it is the only for the 40 route. For an example, if here 100 routers are connected, if 100 routers are connected and we are having 1,000 routes, then what? We need to add 1,000 commands like this. So that would be a very hectic task. As a network engineer, it will become a full-time job in itself. So just imagine, would any company hire that engineers that would be only doing the static routing? No, the answer would be simply no, right? Because when we talk about like routing or when we talk about the network, I think as the less force that we require, less workforce that we require, and getting the better output, that is much better. But when we talk about static routing, here what is required? Each and every router needs to be configured manually, and needs to be added manually. Here I need to add 40, then 50, then 20. Here I need to add 10, 20, 50. Manually we need to add one by one all the routers. Let me show you how. Let me just take you through that. See, I have created this lab, and when we see about here, go to any router and then just enable, and I just let you so run. By default it will be having only 10.110 and 30.110, but if I need to communicate to 20.110, I need to add 40 network, 50 network and 20 network all together one by one. So let me show you the run command and let me show you the configurations. See, I have added 20 network, 40 network and 50 network manually via next hop IP address. That you can see the next hop is the router 1. So now if you see the routing table, you must be able to see, just type show IP route. This is the command to check the routing table. So if you see 10 and 30 are connected, means it is directly connected. Whether 20 network, 40 network and 50 network are manually added to the routing table with the help of a static routing. And this 1-0 is nothing but 1 is an AD value which is determining the trustworthiness of a route. The lowest the AD value, more trustworthy is the route. By default it is the most secure protocol. If we talk about the routing protocols, it is the most secure protocol because here we are manually configuring the routes. But in the same time, but when we talk about the implications, like what can be the consequences when we are applying the static route, here we are only having four routers. Then also I have to configure each and every router with the different routes. Here 30 and 40 is present, so I need to configure 10, 20 and 50. Let me show run. See, here I have configured 10 route, 20 route and 50 route. On this router I have configured 10, 20 and 30. See, 10, 20 and 30. So like this, the routes that are not present in my routing table, I have to add manually. When there is a thousand of routers, then on all the thousands of router, I need to add the routes manually to the routing table. So for this solution, what do we require? We require some dynamic routing protocols. What is this dynamic routing says? What does this dynamic routing says? Let me tell you. Let me take a quick chat if there is any questions. No. Fine. Then, sorry. So what is the dynamic routing then? Like in the previous example, what was happening? We were manually adding the routes to our routing table. For an example, if I am having an R1 router, here I am having, wait a moment. Here I would be having an R2 router. Here I would be having an R3 router. Let me take a 3 router only right now. And here I am having one device A, and here I am having another device. Here I am having another device B. When I want to communicate, here let's take me an example, F0 by 0, F0 by 1, here F0 by 0, F0 by 1, F0 by 0, F0 by 1. IP is 10.1.1.10/24, and here the IP would be 20.1.1.10/24. Here I am going to take 10.1.1.20/24. Let me take here as 30.1.1.10/24, 30.1.1.20/24, and 40.1.1.10/24, 40.1.1.20/24. Here 20.1.1.20/24. Now here by default R1 will maintain two different routes. By default in the R1 routing table, I would be having 30.1.1.0 and 10.1.1.0. And on R2 routing table, I would be having two different routes, 30.1.1.0 and a 40.1.1.0. And on R3, I would be also having two different routes, that is a 40.1.1.0 and 20.1.1.0. So how this is different from the static routing? In the static routing, what we are doing here, we will manually add 20, 40 and 50 that is not present in the routing table. Here also we will manually add 10, 20 and 50. Here also we will manually add 10, 30 and 50. So this will become a hectic task when we go into the real-time environment. So we are having a dynamic routing. What it will do, it will it will share the update packets. Now this routing table will become an update packet for the routers. It will share the routing table information. R1 will R1 will just advertise its updates to R2 and R3. R2 will be advertising its updates to R1 and R3, and R3 will be advertising its updates to R2 and R1. So in this manner, they will automatically advertise their updates with each other by just configuring the routing protocols. By just configuring the routing protocols like OSPF, RIP, or EIGRP. This will help us a lot to establish the neighbor relationships between the different routers and exchange their update packets with each other, so that R1 will exchange to R2 and R3, R2 will exchange to R1 and R3, and R3 will exchange to R2 and R1. So that the routes that are not present into the R2, R3 and R1 routing table, it will automatically add 20, 40 and 50. Here as well it will automatically add 10, 20 and 50. Here as well it will automatically add 10, 30 and 50. So it becomes quite easier for a network administrator to just do one thing, because as a network administrator, if I'm having thousands of routers, it is not even possible for me to understand how the network is created, because there can be the scenarios. First of all, I have added 100 routers, then I have added 50 routers. So the complexity in the network will get increased day by day, day by day. So that would be becoming very much difficult for a network administrator to understand how all the routers are interconnected with each other. So to overcome this problem, what we have developed the routing protocols that establish the dynamic relationships between the router and exchange their routing tables with each other, so that they can create their routing table dynamically. Now let us understand how OSPF is affecting this, how OSPF is just impacting this protocol, dynamic routing protocol, how OSPF creates an impact. Hmm. Then come to introduction to OSPF. OSPF is a standardized link state routing protocol designed to scale efficiently to support larger networks. It is simply saying that it is a link state routing protocol. What does this link state routing protocol mean? It is being used to support a larger network. Means it is supporting unlimited routers. There can be 10 routers, 20 routers, 30 routers, 40 routers. Any amount of routers can be supported with the help of OSPF routers. OSPF protocol, sorry. You can use this OSPF protocol to configure all the routers and establish a dynamic relationship between them. What is a link state? Link state simply says that it will advertise the change only of the links. It is maintaining a whole topological database that is known as LSDB in the OSPF, link state database, which will be containing the information of LSAs, link state advertisements. Here, the OSPF routers will share its routing table to each other. In that routing table, what they are going to exchange? They are going to exchange the LSA information. Means like if any change is occurring onto a particular interface, for an example, this F0 by 1 goes down, so it will not advertise the whole change. Or if any network is added to the router, it will not advertise the whole routing table update to R2 and R3. It will just advertise that particular change that is happening into that particular router. So this is the reason why we call it as a link state routing protocol. Okay. Now let's come different next point. Originally designed in 1980s, OSPF is defined for IP version 4 in the protocol version 2 by RFC 2328 1998. In the 1998, the RFC was declared, where in the version 2 was being used, and still version 2 is used. IP version 6 is being used in the OSPF version 3, which has been developed in the 2008. OSPF version 1 was released with the RFC 1131. This version was only for experimental purpose. Version 1 was not in the use. Right now, the routing protocol that is used in the company's version 2 only. Version 3 is implemented on some of the routers, not on all the routers. OSPF is developed by the IETF, that is an Internet Engineering Task Force, as one of the interior gateway protocol. That is the protocol which aims at moving the packet with a large autonomous system or the routing domain. Obviously, it is supporting the bigger infrastructure, so that is why it has been developed. It's a link state routing protocol that is used the best path between the source and destination router using its own shortest path first. Like algorithm that is being used by the OSPF is the SPF algorithm, that is the shortest path first. OSPF employs a hierarchical network design using the area. You must have seen when I have started the session over there, like when I have created a topology, you see over here. It is some dividing into the areas. What is the reason behind dividing into the areas? The simple reason to divide into the areas is very simple. Like it is maintaining a database information. It is maintaining a database information. R1 will contain the whole topology information, like where R2 is connected, where is R3, where is R4, R5, R6, R7. So if I am having hundreds of routers, so to maintain the database of hundreds of router on each and every router will become very much CPU extensive. Means like it needs a lot of space in the memory, it will consume a lot of RAM, it will use the CPU cycles. So to reduce these things, what we have done, we have divided the OSPF topology into the hierarchical design, where we have divided into the areas. So dividing into the areas, what happens, the routers will only need to maintain the information of that particular area only. Like this, R1 will only have to maintain the database information of R1, R2 and R3, which is in its area 1. Whereas R3 will be maintaining R1, R2, R2, R1, R2 and R3. R2 will maintaining R1, R2 and R3 into the area 1. So the question here will be coming, like how this R1 will communicate with the R7, because the routers will be able to maintain the database of each other only within the area. Here as well, area 0 routers will maintain its database, area 2 routers will maintain its database. But then how it will be going to communicate? So the simple answer for this is that R1 will communicate with the R7, because if you can see, there are some routers which are existing in both the areas. R3 is existing in area 1, area 0, R5 is existing in area 0 and area 2. These routers are known as ABR routers, area border routers, which is having the capability to maintain the multiple area informations. So R3 will be maintaining the information of area 1 and area 0, and so how it is responsible for having communication between area 0 and area 1. It is responsible to have communication between area 0 and area 1, and this R5 is responsible for having communication between area 2 and area 0. So what happens with the help of R5? Area 2 will be receiving the area 0 information and area 0 will be receiving the area 2 information. And similarly, if area 0 information is received to the area 2 and area 2 information is received to the area 0, this will be forwarded to the area 1 with the help of R3. And thus R1 will be able to communicate with the R7. But this is reducing our complexity in the network. This is reducing the database size. This is reducing our overhead of the traffic that has been on the CPU. All things can be reduced with the help of this OSPF protocol while we divide into the areas. Now let us understand like how it is created first of all. So first of all, OSPF forms a neighborship. OSPF forms a neighborship. So to create a neighborship, like OSPF basically maintains the three tables: a neighbor table, a topology table, and a routing table. Routing table is been maintained by each and every routers by default, whereas the neighbor table is containing the list of all neighboring routers. Then you must be wondering, what is neighbor? You might not have heard about this neighbors. Like a topology table is containing a list of all possible routes to all the networks within an area. Here it is written within an area. Yeah, right now I have explained that if I am having a multiple area, the router will maintain the database of particular area only. What can be the contents in that particular topology table? Actual link, the route, the advertising router ID, means who is advertising that particular routing information, the link state age timer, that means in how many times that advertisement will be expired. By default it is of 30 minutes, Every 30 minutes, LSA will be refreshed. The sequence number and checksum for each entry. Sequence number and checksums are some things like which determines the packet's number or the packet size, and checksum is determining if there is any error in that particular packet. So these details are being shown in the OSPF routing table. And when we talk about neighborship, creating neighborship is essential for routers to communicate and exchange information effectively within the same area or across different areas. Here are the key reasons why neighborship is established in the OSPF. Exchange of routing information. Let me just give you a very good example. So you might have uh, called someone. You do call every day. So if you are calling someone, first of all, you do what? You pick up the call and say hello. If the another person says hello, then you are able to understand, like, our connection has been created. Now we can start speaking with each other, right? So this is a scenario in the very real time. When I call someone, so simply I say what? Hello. And the other person who is on the call, he will say an hello, so that I can recognize that there is some another person, so that the communication can happen between both of us. Connection has been established. So this hello is creating a connection simple. In the OSPF, there is an hello packet which is creating the neighborship between the routers. What it is saying, it is creating a neighborship. For an example, if I am having multiple routers, R1 and R2, R1 needs to exchange the information to R2 and R2 needs to exchange the information to R1. So they should need to understand that R2 is there or not, R1 is there or not. So R1 and R2 will exchange the hello packet and form the neighborship. They will understood that R2 is there and R2 will understand R1 is there, and they will form a neighborship, so that after creating the neighborship they can exchange the information. So here it is written exchanging of routing information means OSPF routers establish a neighbor relationships to exchange informations about the networks they can reach. This exchange allows routers to build and maintain routing tables dynamically. This neighborship is already been effectively creating the routing tables. What is the topology database synchronization? This is the another parameter through which neighborship can achieve. Like OSPF routers maintain a synchronized view of the network topology by exchanging the LSAs. LSAs describe the state and connectivity of the routers and links within an OSPF area. By forming neighbor relationships, routers can exchange the LSAs to update and maintain their link state databases. Means like if I am having multiple routers R1, R2, then like when we are sending the hello packets, they are able to understand that this LSA's information is being sent to me and this LSA information being sent to me, and they can create their database tables as well. So this is the information, this is the like main functioning of the neighborship. Why we create a neighbor to exchange the database information, to create the neighborship, to exchange the informations. Now it is been this neighborship is also been created to calculate the shortest path. SPF algorithm. There is an SPF algorithm which is been used to calculate the cost of the path. What is the cost? Let me just show you. Cost is a metric of OSPF. When I have multiple paths from source to destination, if just take an example, there is R1, R2, R3, R4, R5. Like to reach from R1 to R4, I am having a multiple path right now. Either I can go via this or either I can go via this. So how to decide? So basically, when the same routing protocol is implied on both the path, then we have to calculate the metric. We have to calculate the metric of the path. And to calculate the metric, we are having a cost in the case of OSPF. Cost is nothing but the reference bandwidth of a link by interface bandwidth. So for an example, here the link is fast Ethernet, and here it is an Ethernet. Here it is an Ethernet and fast Ethernet. Then how to decide which is a better path? So by default, the reference bandwidth is 100 Mbps. What is that? 100 Mbps. So I have to calculate one by one. Go to the fast Ethernet. It would be 100 by 100. That is 1. Because fast Ethernet the bandwidth speed is 100. If you don't know, the serial link is having a bandwidth of 1.54 Mbps. Ethernet is having a bandwidth of 10 Mbps. Fast Ethernet is having a bandwidth of 100. Gigabit is having a bandwidth of 1000 Mbps. 10 gigabit is having a bandwidth of 10,000 Mbps, and so on. So similarly, Fast Ethernet is having a bandwidth of 100. So reference is 100, interface is 100, the cost become once. Here also the cost become once. Here the cost will become 100 by 10, that is 10. So the total cost on this path will be 10 plus 1 plus 1, that is 12. And similarly here will be 100 by 10, 10, and 100 by 100, that is 1. It will become 11. So by default this is having the lowest cost, so it will make this path as the best path. As a human, we are able to calculate and find it out which is the best path, but machine will be learning on the algorithms, and the algorithm that is being used by the OSPF is known as Dijkstra SPF, that is a shortest path first algorithm, which is being calculated on the basis of cost of the link. This is the also one reason why we call it as a link state routing protocol, because the metric is also based on the link cost. So this was about the neighborship. Now to form a neighborship in OSPF, there is a criteria so for both the routers. Like if I am creating a neighborship, so these two routers should be present into the same area. If this is in the area 0, this should be also into the area 0. Subnet mask should be same. If I am using the slash 24 over here, here it should be also slash 24. Hello and dead timer should be same. Hello timer of OSPF is considered as 10 seconds and dead timer is considered as 40 seconds. So this should be the same, and then the stub flag must match. By going ahead, when you will be going into the depth of OSPF, you would be learning that there are different types of areas. So in that one is a stub area. So if I am taking one router into the stub area, the another router should be into the stub area as well. Then and then only they can create the neighborship. So over there, this stub flag comes into the picture, and authentication must match. There are two types of authentication. One is a plain text and another one is a MD5 authentication. So if I'm using the plain text, both the routers should have the plain text authentication. If I'm using an MD5 authentication, both the routers should be present in the MD5 authentication. This is the criteria to form a neighborship when I'm having two routers. Now next, what is the hello parameter? Now what is the hello parameter? Before proceeding further, let me tell about what is hello actually. What is hello actually? So why do we use a hello? Let me tell you. Just give me a minute, guys. Okay, fine. Let's continue. Then there are some message types in the OSPF. OSPF message types. How OSPF is sharing the database? Let us understand. First of all, the message is hello message, and the second message is database description, that is in the short form DBD. The third is LSR, that is a link state request. Then the fourth one is LSU, that is a link state update. And the fifth one is LS acknowledgement, that is link state acknowledgement. So why do these messages are used? The first question that should be coming in your mind, why do these messages are being used? So first of all, if I am having a R1 router and if I am having the R2 router, R1 will send a hello to R2 and R2 will send a hello to R1. Why? Well, the reason is a neighborship that we have discussed right now. I have to create a neighborship between the routers before exchanging the database. So it will form the neighborship when I exchange the hello. But after exchanging the hello, once the neighborship is formed, then also hello messages are being exchanged every 10 seconds. Every 10 seconds, R1 will send a hello to R2 and R2 will send a hello to R1 every 10 seconds. Why? What can be the reason? Right? Because once the neighborship created, then why do we need to send the hello again and again? The reason behind that is to have a keep alive mechanism so that R1 should know that R2 is alive and R2 should know that R1 is alive. This is the major reason why the hellos are being sent every 10 seconds. Now it comes the database description. What is that? Just take an example. There are multiple routes 10, 20, 30 on R1. There are multiple routes 40, 50, 60 on R2. Now, apart from sending the whole routing table to R2, R1 will send a summary information of R1 to R2. R2 will send a summary information to R1. A summary is sent from here and a summary is sent from here. Now what do will do? What do they will do? They will change their check their routing table. Is the summary is present in my routing table? So if you see right now 10, 20, 30, is it present in the R2 routing table? No, it is not present. And similarly, 40, 50, 60 is also not present in the R1 routing table. So then what they will do? Then for first of all, let us understand R1 has sent this DBD message to R2 and R2 has checked. But R2 found that the information that is included in the summary is not present in my routing table. Then what R2 is going to do? R2 is going to generate one message to the R2 is going to generate one message to the R1, that is LSR, that is link state request. It is my DBD message, and after checking the DBD message, LSR will be sent to R2 to R1. Then R1 will do what? R1 will send an update packet to R1. R2, that is known as LSU. In that update, it will include the information that was been asked by the request. In the request packet, R2 has asked R1 to share the information that was present in the database description that was not present in its routing table. So now R1 is doing what? R1 is sending the update packet to the R2 so that R2 can have the information in its routing table. And after receiving the update packet, R1 still not confirmed that the update packet has been received to the R2 or not. So R2 will do what? R2 will send an acknowledgement to R1 that yes, I have received your update that you have sent to me. So this is the function of messages in the OSPF. Once the acknowledgement is sent from R2 to R1, now R2 will be having all the routes from R1. Similarly, like R2 has sent a hello message to R1, a DBD message to R1. R1 has checked that 40, 50, 60 is not present. It will send a DBD packet. It will send a request, then update, then acknowledgement. This is how they both will exchange the information and create their routing table respectively dynamically. This all thing is happening dynamically. You don't need to do any manual intervention in this thing. This all processes are done dynamically. And now at last they both will be having the same routing table. They both will be having the same routing table after exchanging the information. So this is the role of messages. And what should be the message, what should be the content in the hello message that is been written in the previous slide. Let me show you. The area ID should be there, area type. There are basically different types of areas: stub area, not so stubby, totally not so stubby. Area ID, like if you have seen in the figure, area 0, area 1, area 2, so that is an area ID. Then the prefix is nothing but the slash value, subnet mask, hello interval, dead interval, I have already said. There are different types of networks as well in the OSPF, like broadcasted network, point to point network, point to multi-point network, non-broadcasted network. So that is been included in the hello packet. And authentication, which authentication mechanism is used by the OSPF. So these are some things written in the hello packet about DBT packet, then link state request, then link state update, then link state acknowledgement. After exchanging the link state acknowledgements, now both will be having the same routing tables with each other and they both can communicate. Here we don't need to add manual routes. Now we come to next topic, that is OSPF states. States is nothing but how do these packets are traveling through the particular states. That is a state. So basically there are 7 states in the OSPF. First is down, second is init, third is two-way, fourth is start, then fifth is exchange, then sixth is loading, and the seventh one would be full state. So what do they do? In the down state means like OSPF process had not yet been started. Routers are in the down state. That does not mean that router is not yet started. Router is started, but OSPF is not yet started. In the init state, what happens? R1 will send an hello packet to the R2. R1 will send the first hello to the R2. In it will include its own router ID. Just understand, router ID is a unique identification number given to each and every routers. Just understood that R1 router ID is the R1.1.1.1. R2 router ID is 2.2.2.2. This is an init state where the hello packet has been initiated from one router. Now in the two-way state, what happens? R1, R2. R1 has sent an hello packet to the R2. Now R2 will send a hello packet to R1. In that hello packet, what it is going to send? It is going to send its own router ID plus the router ID it has received. Here in the router ID 1.1.1.1 it has received. But in this hello packet, it will include 1.1.1.1 and 2.2.2.2. So now the receiving router is able to see its own router ID in the receiving hello packet. Means R1 is able to see its own router ID in the receiving hello packet, then R1 will be considered into the two-way state. R1 will be considered into the two-way state. And after that, R1 will again send the hello to R2, and now the R2 will be able to also see its own router ID because it will also set 1.1.1.1 and 2.2.2.2. So now R1 and R2 both will be in the two-way state. So this is a two-way state, and here once the hello is exchanged, the neighborship is formed. The neighborship is formed in two-way state, and here one DR beta election is taken place. To go about the DR beta election, just study further. And then again, after the two-way state, it comes X start state. It comes an X start state. What does this X start state will do? After hello packet, the DBT packet comes into the picture. So in the X start state, nothing is been done. Only, let me just tell you what is happening in the X start. Now once the neighborship is created, R1 and R2 both will exchange the empty DBT packets. Both will exchange empty DBT packets. Why? You must be wondering, I don't have told you about the empty DBT in the packet types. So what is this empty DBT? In this empty DBT, they would be exchanging the MTU values, that is a maximum transmission unit, that is the frame size that is been sent from R1 to R2, that is by default 1500. If R1 is sending 1500, R2 should also send 1500. Why? This is checking the data that I am sending to the R2. Is the R2 is able to send the same amount of data to me or not? So actually this is checking the reliability of the network. If for an example, R2 is unable to send 1500, R2 send 1470, 1460, then what happens? MTU will be mismatched and the neighborship will be stuck in the Xstart state itself. So to move ahead, both the MTU sites should match with each other. Once the empty DBT is exchanged in the Xstart state, they will elect master and slave router. They will elect master and slave router, a master router and a slave router. Master router is doing what? Master router will share its database first and slave router will share its database afterwards. Master router is elected like which is having the highest router ID, it will be the master router, and the lowest router ID will be the slave router. Master and slave are elected in between every neighbors, so that there cannot be any like I will share it's my database first and I will share my database first. So there cannot be a scenario like this. So this is the reason why master and slave election has been done. And after the Xstart state, it will go to exchange state. It will go to exchange state. In the exchange state, what is happening? In the exchange state, it will simply exchange the database with each other. It will simply exchange the database description. Now original DBT comes into the picture. Now sorry, now original DBT, once the empty DBT has been exchanged, now original DBT will be there. R1 and R2 will exchange the original DBD packet. R1 will send the original DBD, which will be containing the summary information of R1, and R2 will be sending the original DBD packet that would be containing the summary information of R2 in the exchange state. Now, once this has happened, they will check their respective routing tables, and after that, in the loading state, LSR, LSU, and LSEC will be exchanged if the routing table is missing some information, if the information is missing from the routing tables. But if it is same, it will simply exchange their LSAs. This is also known as LSAs, link state advertisements. And once all the things are been exchanged, the router are considered to be in the full state. And in the full state, what happens? The routing table of R1 and R2 becomes same. That is known as identical. The routing table will be identical to each other, and this condition will be known as adjacency. The question here one comes into the interviews like, what is the difference between the neighborship and the adjacency? So the neighborship is been created when the hello packets are been exchanged, but whereas adjacency has been created when R1 and R2 or the routers have exchanged their whole routing table with each other. So this is the major difference between the neighborship and adjacency. So this was about packets and states. Good. Now it comes to the area concept. I have already explained that why do we create the area for the scalability purpose, because OSPF is supporting an multiple routers or unlimited routers, so we are having multiple areas, so we can divide the areas. Confinement of network instabilities, like if there is a failure, that will be only accessible to that particular area, that won't go beyond that particular area. If any route fails into the area 0, that will affect that particular area only, it won't affect the another areas. Not area 0, area 1. Area 0 is a backbone area. Administrative control and security. Mechanism for administrative control and security by segregating network resources based on the organizational, geographical, or security requirements. Like it also provides us the security. As an administrator, I can secure my communication through where to where I have to communicate into the internal network by giving the ACLs, access list. Sorry. Now there are different types of router being used in the OSPF. What are those? Let me just give you the brief. The routers, here let me show you in the diagram only, it has been mentioned. Here you can see the routers. By default, if I am taking multiple areas, I have to take one area, that is an area 0, because it is known as a backbone area. If multiple area exists, I have to take an area 0, because without the area 0, no other areas can be communicated. Right, like our backbone, if the backbone got broken, we cannot stand up or we cannot sit down. Similarly, if the connection with the backbone area is broken, no other routers can communicate with each other. So it is very much important. This is a backbone area, and the routers inside the backbone area will be known as backbone routers. Whereas the routers inside any area will be known as internal routers. Will be known as internal routers. Like R1 is an internal router, R2 is an internal router, R3 is an internal router of area 1. Whereas R4, R3 and R5 is an internal router of area 0. And R6, R5 and R7 is an internal router of area 2. Now, like, are you able to see the R3 and R5? They are connecting between two different areas. This is known as ABR, that is an area border router. This is an area border router which is connecting two different areas. This is also an ABR, area border router or area boundary router, which is connecting two different areas to make the communication possible between two or more areas. Whereas there is one more type of router. This is an ASBR. ASBR stands for Autonomous System Boundary Router. At the start, I have told you something about the autonomous system. Means within the single autonomous system, one IGP protocol is running. So for an example, here OSPF is running. Inside this autonomous system, OSPF is running. But on this router, on the another end, these routes are coming from another routing protocol. Might be RIP or EIGRP. Might be EIGRP or RIP. So this router is going to become a ASBR router, Autonomous System Boundary Router. when two different routing protocols work onto the single router, that is known as an ASBR router. Now, how do these communicate with each other? So they are generating some link state advertisements. So LSA1 will be generated by R1, R2, and R3. Means all the router will be generating LSA1, that is a link state advertisement 1. Let me take you through that LSAs as well. Internal router, area border router, backbone router, and ASBR router. We have already discussed. This is the command to configure the router in the OSPF. OSPF router, OSPF, and then I have to give the process ID between 1 to 65535. I can give any process ID so that I can differentiate the traffic. For an example, if some routers are working in the HR domain, then I will be giving that process ID 10. Some into the marketing, I will giving the process ID 20, so that I can easily distinguish between the traffic if there is any kind of failure. So I can distinguish the failure is happening in the marketing department or in the HR department or in which department. So it is just provided for that. Then a network ID, wildcard mask, area, and area ID. Wildcard mask is nothing but an opposite of the subnet mask. If the subnet mask is 255.255.255.0, then the wildcard mask will be 0.0.0.255. This is an opposite one. Here you can also see the wildcard mask calculation. Simple, you have to subnet, you have to different, you have to just minus it from the broadcast address. So if my subnet mask is 255.0.0.0, then it will become 0.255.255.255. And then area and area ID, it can be 1, 0, 2, anything which we have given. OSPF is a link state. There are different types of LSAs. By default, we are using 5 LSAs. Actually, we are using a 5, but there is one more LSA 7, that is a area specific LSA. But by default, only 5 LSAs are generated, and OSPF supports total 11 types of LSAs. So what are those 5 LSA? First is a type 1, that is a router LSA. Contains all the list of the link local to the router and the status and the cost of those links. Like, it is only generated within the area. If I am having 3 routers within the area, they will advertise their updates with the LSA1 with each other. And LSA2 is generated by only designated routers. If is there any DR and BDR routers into the area, then they will be generated LSA2, and it will be also generating within the area. It is also generated within the area, and it is also generated within the area. Now comes the network summary LSA. It is a type 3 LSA. Like if you see in the in this particular example, there is a router 3, that is an ABR router. How it is communicating between two different areas? It is generating an LSA3, that is a network summary LSA, through which it will be advertising the routes of area 1 to the area 0 and area 0 to the area 1, so that area 1 and area 0 can communicate with each other. Because LSA1 is generated within the area, so they will be having their informations within the area only. So how do they will communicate? With the help of LSA3. Now this ASBR router will generate an LSA5. It is an external LSA which is generating the information of external routes, like which is coming outside the OSPF domain. Which is coming outside the OSPF domain, it will be generating this information with the help of LSA5, and it will take a form of default route and spread it to across all the routers which is in the OSPF. All the routers will be knowing about the LSA5. All the routers will be knowing about this particular routes that is been advertised from the different routing protocol into the OSPF, and they will be having this information. Now the question comes, R1 is able to know about this R7? No. R7 has spreaded the information so that R1 is having that information, but R1 does not know where is R7. Where is R7? The reason behind this is it will take a form of default route and it will be spreaded to all the routers. But what about R1, R2, R3? They don't know where exactly R7 is. Only R5 and R6 know where is R7 because they are in their area. So now this ABR router is going to generate one more LSA, that is the LSA4, that is an ASBR summary LSA. So that the routers that are inside its area, they will be able to know that where exactly R7 lies. Where exactly R7 lies. This LSA4 work is simply to let the routers inside its area know where is R7. This R3 and R5 will generate within its area so that area 0 and area 1 will be able to understand exactly where ASBR lies, like so that they can able to understand where the ASBR is. So if the route is exiting the autonomous system, this R1, R2, R3, R4 and R5 would able to understand from which router it is exiting the autonomous system. So this was about the LSAs. Let us perform some lab. Like when LSA is propagated, there are three circumstances the advertisement has been generated. LSA is nothing but the update packets. When a new adjacency is formed, when the routing tables are exchanged, the LSAs will be generated. When a change occurs to any topology table, if there is any particular route added or removed, then the LSA table will be generating an LSA. And when LSA reaches its maximum age, that is 30 minutes by default. If LSA has been 30 minutes done, then also it will be generating the LSAs. Now let us understand some practical experience. See, this is a particular topology. Let us try to see what is the database over here. See how to configure the OSPF. If you see what I have done, I have taken router OSPF process ID as a 10, and then I have just advertised the network and provided the area ID. Network ID, then wildcard mask, area and area ID. If you say I am only having a 10 route information, so I have just advertised that router information only. But I am having all the routers information. Why? Because it is a dynamic routing protocol. So I am just advertising my routing update and all other routers will be advertising their routing update. So if I check my routing table, show IP route. See, I am having all the routes, either it from 1, 2, 3, 10, 20, 30, 40, 50, 60, all routes I am having. But I was only having a route 10 in my network. 20 is coming from OSPF, that is from this router, whereas 30, 40, 50, 60 is coming from OIA. OIA stands for OSPF inter area. That means it is coming from the different area. This ABR is taking this information to my area. 30, 40, 50, 60 all are from the different areas. Whereas this E1 stands for external type 1, where external routes are been coming. Like these routes are advertised on the ASBR router because it is having two different routing protocols. If I show you R7, show run. See, on this particular router, I am having two different routing protocols. One is router OSPF, 60 network is been advertised, and another one is router RIP. RIP. I am having three different networks in the RIP. So this RIP is been redistributed to the OSPF. So it is taking the, by default it will take the form of E2, that is an external type 2. By default metric will be 20, but I have changed it to E1. Why? Because it is not considering the metric to reach from R1 to the R7. It will only take the metric from R7 to this particular RIP routes. That is a 21. So I have changed it to R1 so that I can see the metric as well. Like here, if you can see, options. See, I have given the command redistribute RIP metric type 1. I have changed the type to 1. Why? Because by default it was metric type 2 that was been advertised from the external routers. ASBR was advertising test routes. R1, R2 and R3 is generating LSA1. Let me show you how. You have to check database. Show IP OSPF database. It will show you the topology table. See, I have told you there are 5 types of LSAs. Router LSA is generated by the routers 10, 120 and 30, the routers that are present within the area 1 only. And net link state is generated by DR and BDR routers. Summary LSA is generated by ABR router. See, the network ID is 30110. Sorry, router ID. Router ID is 30110. If you see the router ID of this router, it will be 30110 only. This is my ABR router. So it is taking the information to my router of 30 network, 40 network, 50 network and 60 network. It is taking the information to my particular area. That is an ABR router 31110. If you see the router ID over here, just show IP OSPF data. It is known as a topology table. See, it is having both the area information, area 1 as well and area 0 as well, right? If you see the router ID of this area, router ID is a unique identification number, unique identification IP address given to each and every router. So the router ID for OSPF is 30.1.1.10. So here on R1, if you see, the LSA3 is being generated by ABR router 31110, and it is taking the information of other areas through which R1 is able to communicate to R6. Otherwise, it was not able to do that. Whereas LSA4, summary AS band link set LSA, it is also been generated by the ABR router, that is the area router 3. But it is giving us the information of ASBR router. If you see the router ID of R7, it is 3.3.3.3. Let me show you. Show IP OSPF database. What is the router ID of this particular router? It is 3.3.3.3. So if I see on R1, the LSA4 is being generated by this advertising router is ASBR only, the ABR only, that is the R3. But it is taking the information of particular external router, that is the ASBR router. And type 5 is an external LSA, which is been generated by only the ASBR, and it is telling us the information about the routes that are being generated in the different routing protocols. So this was about the LSAs. When I talk about R3, R3 is maintaining the two different database of area 0 and area 1 because it is an area border router. And it is generating the LSA3 as well, it is generating the LSA4 as well. So when you check each and every router, it will be also having this, like here you can see show IP OSPF database. It was about database table. When we talk about routing table, the command to check the routing table is show IP route. From here we can see the routing table information like 10, 20, 30, 40, 50, 60, all are the routes that are been present in the routing table. Even states that it is an external route. That means it is coming from the different routing protocol. OIS states that it is coming from the different area. O stands for OSPF. And when we talk about neighborship, to check the neighborship, I have to check show IP OSPF neighbors. You can see that particular router. If we talk about this particular router, let me show you. This R4 is having two neighbors, this R3 and R5. So I am able to see the router ID of this 31110 and 51110. So through this I can able to recognize like what are the sort of information that I need to gain from the OSPF. So it is particularly maintaining three tables. One is neighbor table, one is routing table, and one is a topology table. This R7 is an ASBR router, so it will generate the LSA5 information. If you see over here, the type 5 external LSA is been generated by 3.3.3.3, which is the router ID of this particular router only. Whereas it is not generating LSA4. LSA4 is only generated by the ABR routers to its area where the ASBR is not present. So this was some brief about the OSPF. OSPF is actually a very depth protocol. What we have learned today, it's a practical implementation, whereas the theoretical approach as well, when we are constructing the OSPF protocol. So like how you are going to create the topology, how you are going to decide that how many routers I need to connect, whereas how to connect those routers and how to establish the neighborship, how to create the topology, how to maintain that database. These things you will be able to understand from the today's lecture or today's session. I hope it's clear to everyone. Let us come to the topic again. So here are some interview questions that might be helpful for you in the interviews. Like what is OSPF? You can determine what is OSPF, why do we use that OSPF, what is the AD value of OSPF? It's 110. What are OSPF tables? OSPF maintains three tables: neighbor table, topology table, and routing table. How router ID is elected in the OSPF? So for the router ID election, there are particularly three steps. When we talk about, you must have seen the router ID right now. So how I have decided that which is my router ID? So basically, there are three steps. First is a manual configuration. If you manually give the router ID, then it will be taking that router ID. If not, then it will be checking highest loopback interface IP address. Highest loopback interface IP address if you have taken any loopback. But if you have not taken any loopback as well, then it will check for the highest physical interface IP address. So first of all, manually you can give any manual range from 1.1.1.1 to 255.255.255 for whole IPv4 range. It's included. A loopback, for an example, if I'm having a router, there are having physical interfaces as well, and I have taken loopback 1, loopback 2, loopback 3. So which is having the highest loopback address will be considered as the router ID of that particular router. If you have taken the loopback, just for an example, if I show you, I have taken here in this R7. If you see the R7, I have taken loopback 3. So the router ID that was shown on the R7 was 3.3.3.3 itself. Whereas on the another end, when I have shown you the router ID of R3, it was 31.110. Why? Because neither I have given manual configuration, neither the loopback has been taken on R3. So it is going for the highest physical interface IP address. That is the third step. Highest physical interface IP address. So which is the highest one? 21.120 or 31.110? So this become your router ID. So this is how the router ID is been elected dynamically, or if you have given the statically, then it is not going to check the dynamic process as well. So this is the answer of how to elect the router ID in OSPF. Then what are OSPF message types? We have already discussed what are hello parameters to form the neighborship between the two routers. We have already discussed what are OSPF states. We have already discussed why DR is elected, how election takes place. So DR is elected because to like a scenario when the scenario comes to you, if you are having a multi-access segment, multi-access means like one switch is connected, multiple routers is connected, then no routers are having direct neighborship with another routers. So in this scenario, what happens, all the router needs to maintain multiple adjacencies with the routers. So here we will be electing one DR and one BDR so that we can reduce the number of adjacencies, because if we are having 100 or 200 routers, then all the routers will need to maintain the adjacency of each other. Like if 100 routers, then 100 adjacencies, 200 then 200, like it will become very difficult task and routing table will be very much big. So to reduce this thing, we elect DR and BDR. DR is a designated router and BDR is a backup designated router. So DR and BDR will manage the whole traffic of OSPF. DR BDR will take the responsibilities like a manager and assistant manager. By default, the DR will be taking the responsibilities. If this R1 and R2 wants to communicate, it will send the packet to DR and DR will communicate with the R2. Same, and vice versa. But for an example, if DR gets down, then our whole topology will be down. So in that scenario, this BDR will take the responsibility and it will share the database between the routers. So for sharing this database, if DR BDR is sending the database to the DR others, the other routers apart from DR BDR, they are known as DR others, and it will take the multicast address 224.0.0.5, and the DR others, if they are sending the database to DR BDR, they will take the multicast address of 224.0.0.6. This is why. And how it is elected? Same. Highest router ID router is going to become the DR and second highest router ID router is going to become the BDR. By default, it will check for the OSPF priority, but by default, the priority is one of the all the routers. So that's why it is on the router ID. Which multicast is used by DR? It's 224.0.0.5. LSA types we have discussed. LSA 3 is discussed. LSA 5 and LSA 7. It's an output like LSA 7 is a different LSA. It is generated when NSSA area. In future, when you will study about OSPF in detail, then you will be learning about the one type of area that is a not so stable area. So it's like an area specific LSA, whereas LSA 5 is generated when ASBR is there, and where in the NSSA area LSA 5 is not allowed. So that's why LSA 7 takes the responsibility to advertise the networks that are being advertised from the different routing protocols. What is E1 and E2? E1 and E2 are the routes metric which is given to the external routes that are being generated from the under routing protocol from on the ASBR router, whereas E1 is the total cost and E2 is only the external cost. In which condition neighbor stuck in the XStart when the empty mismatches? On what router summarization is done in OSPF? So in ABR, inter-area summarization is done, and on ASBR, external summarization is done. How an area indirectly connected with the different area can have the reachability to the area 0. This is a good concept. Let me tell you what does this statement means. By default, there is a prerequisite that all areas should be must connected with the area 0. But if I am having any case that area 0 is there, like this, area 1 is here, and there is one more area, that is area 2. It is in the area 1 and it is in the area 2. So this area 2 is not connected to the area 0 now. So area 2 won't be able to communicate with this particular area 0. So in these circumstances, what is going to happen? You have to create one virtual link, not a physical link. A virtual link concept comes into the picture of OSPF. A virtual link is been created onto the ABRs. This is an ABR and this is an ABR. The ABR of area 0 and the ABR of the disconnected area, they will be creating one virtual link and having the relationship between the area 0 and area 2. To connect the particular disconnected area to the area 0, we use a virtual link concept. So this was all about in today's workshop. I hope you all have enjoyed, and I would appreciate your feedback. If there is any feedback, just post them in the chats. Thank you. Okay, fine. So I'm going to stop the workshop over here. If is there any chat, let me see the chat. Any questions? Any question there? No questions? I hope you all have enjoyed the sessions. Best of luck for your future, and thank you for attending today's workshop. Have a good day, everyone. Bye bye.